Hello, today we will be learning how to factorize quadratics. As you can observe, we have a quadratic right here with x squared minus 5x plus 6. Now, when you first understand quadratics, you can find that to find this answer, negative 5x, you have to add two numbers. And to find a positive 6, you have to multiply two numbers. Now, the main concept that I want you guys to learn is that when you first factorize quadratics, you have to look at the symbols of these two numbers here, the constant and the x value here. And as we can observe, for this quadratic, we can find that this is a negative and this is a positive. Now, how does that, why does that matter? Why does that matter? Well, since we need two numbers that add up to negative 5x, let's look at through all these rules over here. Alright, so, let's look over here. There is a negative is greater than a positive, and it results in a negative number. So when you add a negative number that is bigger than a positive number, that results in a negative result. If you have a positive number that is greater than a negative number, it will equal in a positive number. Now if you have a negative number with another negative number, it equals a negative number, and a positive plus a positive is a positive number. Now what does that mean? Well, if we want a negative 5x, that would mean if we tried to do a bigger positive number than a negative answer, such as 10 plus negative 5, so that's the smaller negative number, it would equal into a positive 5, right? Now, for this kind of concept, we don't want a positive number, because we want a negative 5x. So this wouldn't work. Let's try this. A positive plus a positive equals a positive. Now if we had 10 plus 10 equals 20, we have another positive number, and we don't want positives, remember? Just from looking at the quadratic equation, we need two numbers that add up to a negative number and results in 5. Now, right now, don't really worry too much about the 5, just think about the negative. You want something to add up to a negative. Now, the two rules that I have identified here in the green, that equals a negative is greater than positive is equal to negative, and a negative plus a negative is a negative. So let's write that out. So this one here, negative is greater than positive equals a negative. So if we say we have a negative 10 plus a positive smaller number like 5, that would equal to negative 5. Perfect, we're trying to find negative 5. And, well, it doesn't certainly need to be like this. It could be negative 20 plus 2 equals negative 18. All we want to find is that this is a negative number. It results in a negative number, and we want to find the negatives. So we can find that this rule already applies. Or does it? Because when we first go on to trying this one, we could do negative 1 plus a negative 2, and that would result in another negative number, a negative 3. So we have two possible areas where we can determine what the actual answer will come out as, and what the numbers we will have to use will be. So you know how like factorized answers have like negative 1 or x plus 5? This will help you by just identifying the first two symbols on the quadratic equation on whether they will be both negatives, so like such as x take 1 and x take 2, like those are negative numbers, negative 1, negative 2, or it will help us identify, will it be either a negative and a positive, so we can see a negative and a positive, and maybe it's a x take 1, which is a negative, and then it can be x plus 5. It could be that. And we could be like, okay, so just from knowing that it has to be a negative answer that is bigger than positive, that means that it should be negative 5 instead of negative 1, and that it's a smaller positive number. That means that it has to be an x plus a smaller number such as 1. And so we can identify that the negative number should be the bigger number, and the positive number should be the smaller number to equal a negative 5x. Hopefully you haven't confused right there, but let's move on to some more clarification. So we need two numbers that can add up to a negative number, and we have identified that this is 1 and this is 1 that can add up to a negative and a negative, right? Perfect. Now we move on to two numbers that can multiply. These two numbers have to be the same as these to multiply into a positive 6. So let's just quickly see. We have a positive 6, so let's test this out. A negative and a positive. So if we were to do a negative multiply with a positive, that would equal a negative. We can already find that we have a negative result, and we don't actually want a negative result. We have a positive 6. That wouldn't work out. But let's try the negative and positive, negative add with a negative. So we already know that this won't work and this won't work for the quadratic. So let's see this. A negative plus a negative is equal to a negative. So let's see. So we have identified that there will be two negatives when we factorize. So that would be like x take 1 and x take 2, right? These are both negatives. That is what we're trying to identify. We're not trying to identify the actual numbers, but we're trying to identify if they will be a positive or negative number that add up to each other and multiply to each other. And so let's see. Negative times a negative. That equals a positive, as you can see right here. It equals a positive. Perfect. So we found that this one, a negative plus a negative, is equal to a negative result. And we know that, and we found that with these two negatives, negative times negative equals a positive. And we have a positive. So, through our rules, it should be that when we factorize this quadratic, it will be having some kind of form of like a negative number, for example, like this. It will have some form of two negative numbers. If it was like a plus and a minus, or a plus or a minus here, then it would be like x plus 1 and then x minus 0.5 or something, right? It would have a positive number, as here, such. It's a bigger number, so it's 1, and then this is a smaller negative number, so it's negative 0.5, and it's a negative. So, just from looking at those little symbols in the beginning of a quadratic equation, you can identify a lot of things. So, let's just try solving it. So, let's do it. Let's see if by observing just the two symbols that we can just observe with the negative and the positive, let's see if when we factorize this, will it become two negative factorized answers? Will it be anything else? Let's try it out. Alright, so let me just minimize all of these random things on the side and let's try it out. Alright, so let's actually start getting into the factorizing part. Now this is probably where you came in for, or maybe you have come here for the little concepts. But let's do it now. So, what you want to do when you first observe a quadratic is firstly observe the symbols, and after observing the symbols, we have identified that it is a negative times a negative equals a positive, and a negative plus a negative equals a negative result. So we know that the two factors will be negative. So we're going to do this really cool cross method like kind of thing. So, but first off, before that obviously, we actually have to get into that. Now how do you do that? So you know how in a quadratic formula or just looking at quadratics, you denote them as letters. So we denote this as A, we denote this as B, and we say this is C because this is a constant. Well, we kind of do it like that. So let's find the factors of A, which is x squared. What are the factors of x squared? Well, the factors of x squared are basically what times something to equal that result. And the only thing for this one is x. X times x itself turns into x squared. So when you times them, x times x equals x squared. Does that match? X squared and x squared. Does that match? Yes, it does. Perfect. We're already on the right track. Now, let's go and find the factors of 6. So we find the factors of c. Now, what are the factors of c? So let's check that out. Really simple. It's not that difficult. We write down the factors of c. So we know that 1 times 6 is equal to 6. We know that 2 times 3 is equal to 6. And those are the only factors of 6 that we can find. So, we know that we're going to have two negative results, right? So, just from analyzing, we know there's going to be two negative results. And by negative plus a negative equals a negative result. That means one of these factors here will add up to negative 5x. Now, it can't be 1 and 6, because if negative 6 plus negative 1 result in negative 7, and we don't want that. But think about it, if it was negative 2 plus a negative 3, that would equal negative 5. So just from looking and identifying that so easily, we can figure out that this these are both negative, so we write down the negative signs, and we write down the factors that actually work, which is 2 and 3. So it doesn't matter which way you put them for now, because it's a monic polynomial, monoquadratic, sorry, or monopolynomial, I guess you could say. Which mono means 1, so the coefficient in front of x squared is 1. But when you first handle like different quadratics such as 2 or 3, they get way harder, and you have to actually consider which rearrangement these numbers should be placed in. But we're not going to worry about that just yet, okay? So let's just solve this. So we know that these are the factors, so we put them in. So we know they're negative, so as we have determined here. And so let's try it out now. -3, -2. And what we do is we cross multiply them. So cross multiply, so you just times that and times that. So x times -3 is -3x. X times -2 is -2x. So we add these instead of multiply them. We add them, because remember this is add. So we add these, right? So that equals -5x. Is that correct? -5x, -5x, yep. And x squared matches x squared, yep. Now, the last thing we have to do right now is to identify if these things will match up. So, if these numbers will multiply, remember that's to find this you have to multiply. Well, let's see if they will multiply into +6. -3 times -2, guess what? Equals +6. So +6 matches, -5x matches, and x squared matches. So from just doing that little like boxy quadratic like cross multiplication little technique that I just showed you to find the factors of a, which is x times x, and factors of c, which is 2 and 3, and from using our technique that we observed to identify if the factors was negative or positive, or which one is positive or which one is negative, we have identified that those two factors are negative, so that's why we have negative and negative factors, -3 and -2. We have found the factors of 6, which is these two factors, but we have identified that this is the perfect factor to solve this quadratic. And we have found the factors of x, which is quite simple. X times x equals x squared. So, what do we do now? You may be asking. Maybe your question is asking you to find the result of x. What is x? And you don't know how to. Or maybe it's just factorize it, and you're only up to this stage and you don't know how to factorize. Well, this is a really simple thing. You just kind of grab this, and you just grab this, and you just write it down. So it's actually just x take 3, bracket, 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 x take 2. And that's it. That's your factorized form of the quadratic. It was just that simple. You find the factors of a, you find the factors of 6, and then you have to, obviously before that, you have to see which concept works. Is it this one, this one, this one, or this one? Does it multiply like this? Does it multiply like that? Does it multiply like that? Or does it add like this? And from identifying those little key things, you will find that you're actually going way faster at solving quadratics than you were before. Now, maybe your question asks you to actually solve what x is. So what you can do is use the null factor theorem, in which you make it equal to 0. And all you do is you just bring it like this. I'll show you how to do it. So x take 3 and x take 2. Let's do it portion by portion. Let's do this portion first. So that means x take 3 equals 0. And when you balance something out, right, when you want to get rid of the -3, what you do is you add 3 with it. And you want to do on the other side, if you do on one side, you have to do the other side. So you add 3 on this side, you have to add 3 on that side. And you get rid of the 3 because they cancel out. And 0 plus 3 is 3, so that means x is equal to 3. Let's do the same with x take 2. So let's do this portion now. X take 2 equals 0. When you want to get rid of the 2, you add 2. So you do on one side, you have to do on the other side. So you add 2 on the other side. That results in x equal to 2. So the two possible values for x that will work on this quadratic is x equals to 2 and x is equal to 3. And there you go. And that's how you factorize, and that's how you solve it. But one thing you have to keep in mind is a really good way to check if you're right is you can also double check by expanding the factorized form. So let's use the FOIL technique. If you don't know, just search it up on Google or YouTube and you'll be able to find out. But I'll just solve it right now. So x times x is x squared. X times negative 2 is negative 2x. Negative 3 times x is negative 3x. And negative 3 times negative 2 is positive 6. You add these together, the negative 5x. And therefore you have x squared take 5x plus 6, and it's the same, x squared take 5x plus 6. And that's how you can double check your answer if it's correct or not. And that's how you factorize a quadratic. By identifying using this technique, if I can grab hold onto it, by observing the symbols, if it's negative or positive, you can identify what the results of the factors are. So remember how we said that the results, the answers, will be negative and negative? Well, we were right. It was x take 3 and it was x take 2. They were both negative. So that just proves how this works. So that means that this is a very effective way, but you still need to be careful when you deal with these, right? So let's try a different thing. I see. Alright. So let's try doing another one and we'll end it off with there. And hopefully I haven't confused you too much. If I have, well, oopsie daisy. I'm not the greatest person in the world, am I? Nah. Alright. So, alright. What do we want to do? Alright, let's do this. We want to do 2x squared plus 7x plus 3. So as you can see, this is a non-monic polynomial or non-monic quadratic, which means that there's a coefficient in front of x squared. And so we have 2x squared plus 7x plus 3. Now it's just simple as it, remember? Let's first look at the symbols. This is a positive and this is a positive. Now what does this mean? That means this adds, remember? That means that there has to be a positive number that is either greater than a negative number to equal a positive. Or it has to be a positive adding with a positive number to create a positive. Now as we can observe, a positive bigger number of a positive greater than a negative, smaller negative number, such as like a bigger number that is positive 10, plus a smaller negative number such as negative 7 will still be a positive. And we can see that it's 3. So it's a positive. And for the same here, it's just like a positive number plus a positive number is a positive number. So like 5 plus 5 equals 10, right? It's a positive 10. It's not a negative 10. I don't know how it could be a negative 10, actually. If you manage to do that, you're quite expert at failing. Nah. Anyways, so we can identify that it has to be these two, because first of all, while looking at the addition rules here, these 4 addition rules here, we can identify that this is a negative, this equals a negative, and we don't want negatives, so as you can see, this is a positive addition. When you add them, it becomes a positive. So we can only use these 2 rules here. Now, after identifying that, we also have to identify this symbol. It's a positive as well. Now, if you see that this one is a positive and negative, right? A positive and a negative. So a positive like plus a smaller negative number equals a positive, right? That means that we have to have a positive number and a negative number multiply with each other. So positive times a negative equals, remember this is, you have to find this number, you have to multiply. Well, if you multiply a positive number times a negative number, that equals a negative result. And, well, you can see of the rules here, positive times a negative equals a negative. And we don't want a negative. Remember, we have a positive 3. If it was a negative 3, it wouldn't make sense, but it's a positive 3. So the only reasonable answer that would make sense would be from this one, if it was positive plus a positive, because a positive plus a positive creates a positive, right? We want a positive 7x when you add, and a positive times a positive also creates a positive result. And there we go. So just from analyzing the two symbols, the result, the final result when we factorize it, should result in some number being a positive, such as like an example of like this, where this is a positive 2 and this is a positive 1. It should resemble some sort of positive number. It doesn't need to be 2 or 1. I'm just putting them as an example. It just has to be a positive number. So let's factorize it and see if our rule applies. So this is a non-mnemonic quadratic, so you may get confused, but it's really simple, right? So 2x squared. What are the factors of 2x squared? Well, one of them have to be 2x, and the other one has to be x, because 2x times x equals 2x squared, because it's basically just 2x times 1x, and 2 times 1 is 2. So let's write that down, 2. And x times x is x squared. Remember, when x times x, that equals x squared. But when x plus x, that equals 2x. Don't confuse them together. Please keep that in mind. So this equals 2x squared. Does that match up? Yes, perfect. Alright. And let's find the factors of 3. So it's not a composite number. What's it called? I can't remember. But anyways, factors of 3 is 1 and 3. That's all it can do. It can't be any other numbers that multiply to create 3. So we know it's 1 and 3. And we know that this is a positive 7, which is a greater positive number. Really just from observing this, you can observe that the 3 has to be down here, because when you times these, it creates 6x, and when you times with the 1 over here, it creates plus 1x, and when you add them together, it creates 7x, which is a positive 7x. And, for example, let's say you did accidentally just put the 3 up here and you put the 1 here, and these are the only factors for 3 anyways, and you find that this is 3x plus 2x equals 5x, right, when you add them, and it's not 7x, and you know that this is the only factor, or even if there were more factors, it just didn't work. What you can do is you can just move it, just rearrange it, put the 3 down here this time, and put the 1 over here, and you can just try it again, and if it still doesn't work, then you use another factor. So say if there was another factor, you would use that new factor and test it out, and you would do another factor and test it out, and if it seems reasonable enough, then boom, you won the lottery. I guess I'm not. And so let's just do it this way. 2x, remember we cross multiply, and we put the factors on this side, and we put the factors of x on this side. We find the factors of c, remember? So, remember, so we cross multiply each other. So 2x times 3 is 6x. 1x times 1 is x still, and you add them, and that's 7x. 7x, which is a positive 7x. 7 to positive. Oh, sorry. I'm speaking way too fast. Positive 7x matches up with this positive 7x. Perfect. Alright, last thing we need to check. When these two factors multiply each other, do they equal a positive number? Now remember how we still haven't done, well, you know how we normally supposed to write if this is a negative or positive here? We still haven't done that. I don't know why I keep on skipping that. That's my fault. But what we can identify is, remember how we identified in the beginning, before we even started, that these would be positive plus a positive. Positive plus a positive equals a positive, and a positive times a positive equals a positive. Well, we know that these have to be positive, just from identifying that from the beginning. Just from the beginning when we looked at the equation, or at the quadratic, not the equation. So these have to be positive, so we write the positive signs with both of these, and we can observe that positive 1 times positive 3 is 3, which is a positive. 2x squared, positive, plus 3, positive, plus 7x, positive. And we can grab our little wonderful results, which is 2x plus 1 and 1x plus 3, and we can write that down as 2x plus 1. So it's a plus 1, alright, so we already matched that up, perfect. Let's see if we can match the next one if it's a plus. X plus 3. It's a plus. So, from when we started analyzing the two symbols here, we have already found practically half of the result that we were supposed to find. Because boom, these are positives. It's so good of a rule to keep in mind. So that just proves that yes, by applying our knowledge on observing these signs, the positive signs, we can identify that out of all of these rules, it could be one of these rules that work. Now, I might just do one more because I want to convey to you an interesting thing. Alright? I want to convey to you something that is different. Because these have been negative and negatives and positive. So I want to show you something different. Something that might be a bit confusing, but I'm sure you guys are talented enough to do so. So we have a coefficient of 3, we have a positive 25, so we have a positive. But then we have a negative 18 constant. Have you guys ever encountered that? No, maybe not, so let's be careful. Alright, so let's just get rid of these little markings and let's identify together. So this is a positive 25x, so we can identify that when you add two numbers, they have to be equal to a positive. So let's look at the add section. So we don't want negatives because this is a positive, so we can only be this or this. And then we see that this is a negative 18, so two numbers have to multiply. The same two numbers that add up to 25 also have to multiply together to equal negative 18. And it's a negative, right? And well, if you look at the two results, we have this one and we have this one. We have x plus a minus a negative, which x is greater, x is a bigger number than the negative number, is equal to a positive. And we have a positive plus a positive equals a positive. And we have to multiply these to a negative number, and they also should add up to a positive number. So a greater positive number plus a negative number equals a positive. So we got that correct. It's a positive number, yep. Positive plus a positive is a positive. We got that correct. A positive. Oh, sorry. I really lost it just there. I wrote an x instead of a positive. So a positive times, so since this is a positive, this is a negative, we can do this. Positive times a negative equals, well, guess what? A negative. Perfect. It matches up with the negative 18 and it adds up to a positive. Well, guess what? When a positive times a positive, it creates a positive. It doesn't create a negative. So from just that, positive does not match up with negative, and positive matches up with this adding, and the negative matches up with the multiplication of the negative. Therefore, the factors that we will end up will be something around, like an example of this, will be around like a positive something, positive number, and it will be a negative number. It will be somewhere around there. So we can already identify that one of the numbers will be positive and one of the numbers will be negative. But what you can identify is that this one was correct. So let me just get rid of this. This rule here was correct. We found that when you add them together, they add to 25. When you multiply them, they multiply to a negative number. But what you can identify from this rule is that it is positive greater than a negative is equal to a positive. So a greater positive number such as 10, when added with a smaller negative number such as negative 5, is still equal to a positive number, right? Well, that means that the factors of 18, which is 1, 18, 2, 9, 3, and 6, the positive number has to be the bigger number. So it has to be either 8, 9, or 6. It cannot be the negative number cannot be the larger number in the factors. It cannot be negative 6, it cannot be negative 9, it cannot be negative 8. You know why? Because just for example, if the negative number was bigger, it would be this. Negative 9 plus 2 equals what? Results in negative number. And we have a positive. That doesn't work. But when we apply this rule where the positive number is bigger than the negative number, so negative 9 is bigger than the negative 2, we could say that as, if the bigger number, such as 9, which is a positive 9, added with a smaller negative number, such as -2, will result in a positive number. And that is what we're trying to aim for. So that's what you have to clear. So when you find the factors of 18, the number in the factors, like 1, 9, and 2, 9, and 118, the bigger numbers on the factors will have to be the positive number. Will have to be the +9 or the +18, because that is the only way when you add them will it become a positive 25 or positive number. And the other one has to obviously be like a negative number, because when you have to multiply them, they have to be equal to a negative number. So let's factorize it. I know I'm dilly-dallying a lot, but I really want you guys to understand this concept, because it's a very important concept. I think it's very helpful to actually grasp and understand. So let's get going. 3x squared, right? Easy, simple. 3x. So, 3, that's the factors of 3 is 1 and 3, so it can only be 1 and 3, so, 1 is down here, and we know that x times x. So 3 times 1 is 3, x times x is x squared. 3x squared works out perfectly well. Alright, let's go with -18. What are the factors of 18? Forget about the negative sign, just think about the 18. What are the factors of 18? We have 1, 18, we have 2, 9, and we have 3, 6. I believe that's all there is, but maybe I'm wrong. I'm just like to think about it anymore. Alright, so I feel like one of the bigger numbers have to be positive, because we know that this is positive is sorry, I keep on making the x sign. Positive is greater than negative, right? So one of these, the 8, 9, or 6 has to be the positive number when you add them. So I'd say, well 6 times, let's try this one, the factors of 3 and 6. I don't know if this is right, I don't know if this is wrong, let's try it out. So let's put that there, let's put that there. And the reason why I put this in a line when you cross multiply these two, which are 3x and the 6, is because you want the bigger number that is positive to be the largest number in the thing. So this is why I put it with the 3x. I pair it with the 3x, so that this can be a really big number. So 6 times 3 is 6, 12, 18. 18 plus 3x is 21x, and that is wrong. So we can just from that we already know that. Well, like, let me solve this for you guys. 18x, 1x times 3, 3x equals 21x. That is wrong. That does not add up to 25x. And even if we flip it, it will create a lower answer, because when you put 3 down here and you put 6 up here, it will create 6x and 9x, and that will create 15x, which is less than 18x before. So just from experimenting both ways, rearranging it does not work. So we know that this factor, sadly, does not work. So let's try 2 and 9. Maybe that will work. So I'll put 9 because I want it to be the positive number. Put 9 there, and I'll put 2 there. And remember, the smaller number has to be negative, because we want negative number to be smaller and the bigger number to be positive. So we create that positive. So 3x plus... Oh, sorry, so then that would mean that 3 and 6 would be a lower number. It would be like 15x, because it would be -3 plus 18x, which would be would be 15x, and that wouldn't work out even that would work. Then that wouldn't even work out at all. And so let's try this out. So 3x times 9, 9, 18, 27. Okay, so 27x, and remember this is a positive. And 1x times -2 is -2x, and when you add them together, -2x plus +7x results in 25x, which is a positive, because there's a big greater positive number when you add with a negative number. So it's 25x, positive 25x, positive 3x squared, positive 3x squared. Now let's see if this works. -2 times -9. -2 times positive 9. That results in -18. So yeah, that matches. Perfect. Let's get rid of all these little scribbly lines, and let's see if, when we first said that the example results will equal a positive result, a positive number, and will result in a negative number as well. So let's see if that is correct. So when we grab these, we have 3x, that's a weird x, take 2, that's a negative. We have one of the negatives, click that off, and we have x plus 9. We have a positive, take that off. And so just from observing from the beginning, and just looking at the quadratic, you can observe what the final results will be. If it will be one of them will be positive, one of them will be negative, right? Positive, negative, positive, negative. So the results are 3x take 2 and x plus 9, and if you want to find the x value, you just do null factor theorem, make this equal to 0. 3x take 2, right? So let's just get rid of all this garbage. 3x plus 2, right? Is equal to 0 after doing that. So let's do this compartment first together. 3x take 2, not plus 2, equals 0. You want to get rid of the 2, so you add it with 2, and you do it on the side as well. And that would equal to 2. And you want to divide by 3 on both sides, because you want to get rid of this 3, and these cancel out, and that equals x is equal to 2 over 3. Simple balancing. And then x plus 4, x plus 9, sorry, jeez. X plus 9, so let's do this one now. Let's do this. X plus 9 equals 0. Get rid of the 9, so you take away 9, cancel those out, take away 9, you do on one side, you have to do on the other side, we take away 9 on this side, we have to take away a 9 on that side. X equals negative 9. Therefore, the two values that x works for this equation are x is equal to negative 9 and x is equal to 2 over 3. And that is your x values for that question. If you were to solve, if they ask you to factorize, you factorize and keep it in the form of 3x take 2 and x plus 9. That is the most factorized form. But if you want to find, if they're asking you to find x, then you would use null factor theorem to find x value. I hope you enjoyed learning about how incredible it is and how important it is to analyze the symbols in front of the constant and the x value here. And I hope you can write the notes on this little thingy here about add and multiply. So let me just get rid of all of this here, so we can really highlight everything here so you can understand it. Let's enlarge it. And there you go. So those are the rules. Those are the 4 adding rules, and those are the 3 multiplication rules. Maybe there's more, you can tell me in the comments, but I think that's it. Thank you for listening. Hopefully you gained a lot more insight about quadratics. And yeah, have a nice day. Bye.